We're gonna be
Just
there
let
some
us feel success.
equation.
I am letting you feel success, but I'm not letting you be, caught off guard by it. Because here's the truth. I designed the class, I designed this lesson in this segment to flow to where you would understand it. Because here's the thing. Could you do Prof Bob right now? Might be one or two of you in here that might be able to successfully do it. But my goal is I want a bunch of you to be successfully at it. So, what have I done? I showed you Prof Bob as hard as it's going to get. I brought it down to the base level. We're doing the base level so you know each step. Why do you feel like you got this right now? Because I brought it down this level on purpose. I'm building your confidence to go into harder problems that we're going to go into today. So then what's going to happen whenever someone gets stumped and they're like, I don't know what to do. Yeah, you do. You just combine those two steps you did. It's called education.
So basically the Steelers before and after being Roethlisberger.
Shut up about my Steelers.
Okay.
Who do you even like, David?
I don't want to talk about it. A few days injured right now.
Oh, please tell me. Are you a Vikings fan?
He's a Packers fan.
Packers?
Yeah. Right.
Which I can't hate.
That's such a judgmental look on your
Okay, no, that's why I drink my coffee, because honestly, you can't say much. Everybody looks and says, y'all are idiots getting rid of Aaron Rodgers, and then Jordan Love comes out, and it's like, he's
thought
good.
Aaron was gone.
The scariest part about that is he's more hard than Rodgers.
All right, so here we go.
This is Chuck.
I think you guys have this. You guys are doing very well. So far, we've done a mass to moles, and we've done a moles to mass, and we've done a moles to atoms, particles, molecules, formula units, and atoms, particles, molecules, formula units to moles. So this morning, what we're going to do is we're going from a volume to mole, and then we're going from a mole to a volume. That covers every type of conversion you can hit. Mr. Hall forgot to tell you something on this. Both of these are at STP.
I was kind of hoping so. So glad we could.
Well, no, we wouldn't have to do the problem if it was.
Yeah.
But not possible.
Is it?
No, on the entry slip. The whole map we did?
Yeah, but I'm saying on the entry slip, like I didn't tell you that it's at the standard temperature and pressure. I have to tell you it's at standard temperature and pressure so you can do it. I meant for you to solve these. I did. I was trying to get something to work this morning that wouldn't work, and then I was kind of pressed, so I typed these out really quick. To determine how many moles are in a 12.6 liter sample of volume. So question to you, where am I starting?
Volume.
How do you know we're at volume?
We're at liters. 12.6 liters.
Liters, the unit tells you. Units are your friend, units matter. 12.6 liters, so I'm starting at a volume. Where am I going? How do you know I'm going to moles?
Does it ask you for moles?
I ask you for how many moles?
Looks like you.
Can you go straight from volume to moles?
Yes.
Yes, we can. So let's take our number, set it over 1. So 12.6 liters of fluorine. Hey, what's special about fluorine?
Couldn't tell you.
Oh,
It's,
one of the L
it's one of the
numbers.
7.
Diatomics, very good. So, F2.
That's just weird.
Yeah.
Would I hold it against you if you didn't put F2 there? I wouldn't hold it against you if you didn't put F2 at the end. I would hold it against you if you didn't put moles at the end of it.
I put that.
Why am I talking about fluorine's a diatomic? Because I'm trying to get your head caught up on that so that, whenever I trick you later on, that you look and go, "Ah, you got me." So we set up our conversion factor. What goes on top I know you know it because I literally had two people discussing it and saying, you got this on the bottom, it's supposed to be on the top. Blah, 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 blah. I got it on the top. Oh, you do. Never mind. Anyway, what goes on the top?
Moles.
1.
Mole. Molly, 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 molly. So 1 mole. Bottom.
22.4 liters.
How do you know that?
You told us that number mattered the other day.
Yes. What the 22.4 liters is, that is the volume of 1 mole of a gas at standard temperature and pressure. Any gas, 1 mole of it.
That's some nerd stuff right there. If you know what that is, there on.
You just call me a nerd.
Clear something.
I did have a serious question.
Ask
What in the world, I know what Avogadro's number is, but how did they get 6.022 times 10 to the 23rd?
Through calculations and experimentation.
Of what?
Of liters of fluorine cancel, different samples.
I sure hope that
It's just a weird number.
So,
Random.
they ended up using, I won't say it was a gas, they ended up using,
Yeah.
and Avogadro is actually the first one that theorized it, that said that inside of 1 mole of gas, there are 6.022 times 10 to the 23 particles inside of it. Nobody would actually accept the idea. Avogadro dies, and then they do some experimentation, and they find out that Avogadro was right. So then they named the number, Avogadro's number, in remembrance of him. Yes?
Well, since his name was like so weirdly spelled and everything, was he one of the dyslexic scientists that?
No.
Okay, well,
I have the wrong number here.
yeah.
Jesus. All right, so you should get 0.5625 moles. How many did you get that?
I did.
I got like one person kind of like chicken armed.
I got one of them.
Hopefully you're getting these. All right, let's go to the second one. Determine the volume of 1.77 moles sample of carbon dioxide at standard temperature and pressure, because Mr. Hall should have included that. Where am I starting? How you know I started at the moles?
The unit.
Because the unit, I tell you, what unit's with the number? Hey, I'm gonna give you like a good little trick. Like there's like about 4 or 5 problems typically on the ACT that you can literally just work through and solve or something just based off of units. It's a beautiful thing if you use units. Hey, did I mention units matter? Hey, where are we going?
Volume.
Units have routes.
Volume. I heard your sarcasm, by the way, once or twice.
What?
Well, what day you said we were doing that lab?
I'm gonna move the lab to next week. I was gonna do it tomorrow, but I'm gonna move it to next week because I have your mind set on this and I need to get you set to where you're able to do really hard problems.
Well, we had your name in the group chat set to the Mr. Hall Love Club. It's going back to the Hay Club. Because he decided.
I don't believe you for a second.
He made it to the Hay Club. I changed it to the Love Club. You're welcome.
See, Caden loves me, unlike some people. Anyway, moles to volume. Can I go straight from moles to volume?
Yes.
Yes, we can, yes. So, take the number, set it over 1. 1.77 moles over 1. What unit goes with this number 1 right here?
Nothing.
Hell.
Thank you, nothing. Nothing goes here. So this is moles of carbon dioxide. Now we gotta set up a conversion factor, yeah?
Yep.
Yeah, we do. You bet your bottom dollar. You set the conversion factor. What's going in the top?
22.4.
22.4.
How you know that?
Liters.
Again,
But
that's
I
why you
don't
told me.
know, because I guess we're going to volume.
You're going to volume, so what goes in the top is volume. That's where I want to go. 22.4 liters carbon dioxide. What goes in the bottom?
No, 1 mole.
Well, okay, well why does 1 mole go on the
Because
bottom?
we're leaving
Because we'll
volume.
leave them all.
I leave moles. Moles cancel. Math be mathing.
39.648 liters.
F2.
That was up here, this is carbon
Oh, I
dioxide.
wasn't paying, CO2.
Butter,
What'd you say it was again, 39
648.
liters of carbon dioxide?
That one.
How you feeling?
Amazing.
That's true.
Yeah.
Does that say CO3 or the end of that?
CO3. CO2, sorry. There should be a 2. My marker curled. Hey, how are we feeling? Feeling good? Okay, this is good. I want you having confidence right now, because here's the thing. Guess what I've taught you? I've taught you how to do mole conversions. No matter how hard the problem is, I've taught you how to do a mole conversion. No matter how big the problem is, I've taught you how to do a mole conversion.
Except what did that one say? Calculating the average common number?
Calculating molecular mass.
Yeah, average common mass.
Don't worry, that's the next thing we're gonna do. So, here's what we're gonna do now. I need you to understand, you've done every step we possibly can do. You've went from mass to mole, mole to mass. You've went mole to atoms, particles, molecules, formula units, atoms, particles, molecules, formula units, back to mole. You've went mole to volume, volume to mole. So you can do any of it. You can go mole, you can go mass, mole, atoms. You can go mass, mole, volume, volume, mole, mass. You can do either one of these. Now, we're going to kick it up. You should have confidence in yourself right now. Keep the confidence. These problems are bigger, but the only thing that's bigger here is the steps that you're going to do. Look at it that way. Don't look at it as the large mess that you got to deal with, okay? And besides that, you all can thank my wife. I was talking to her last night about the problem that I wanted to do, and I was like, I could combine multiple tricks. And she looked at me and said, no, you can't do that. You need to save that for them. And let me give you the translation of what that is in woman talk. That's mean. Don't do that.
Yeah, build them up now so you can crush their fears later.
So here we go, okay? We're going to step it up a little bit, but not step it up too massively back.
Well, I like the confidence in you saying that.
Thanks, man.
We're trying to take care of it.
You too, man.
That's right.
Like Mr. Hogg kick out of our individual.
I would too if I was a Steelers fan. No, that's what they're not. Oh, you're a Steelers fan, not that
Yeah, buddy, calm down.
So determine the number of molecules
I can touch it, you can't.
in a
He can't.
Okay. But wow. Oh, you see, we played in a Brazil game.
molecules in a 10.7
No, I was
kilogram
asking,
sample
what,
It's because we were green and stuff.
of
no, that's.
calcium
That's
hydroxide.
not what I was asking.
We're 0-1 because we got cursed.
Other than one, yeah.
Yeah, we got cursed. We, stopped wearing green.
Just the-
Yeah, no, it's
So,
easy from-
Here's what I'm asking you to do. I want you to determine
One another.
the number of molecules in a 10.7 kilogram sample of calcium hydroxide. I'm not going to release you to try this on your own yet. I'm going to work through it. Right now what I'm doing is I'm talking so that you can write it down.
Oh, my bad.
Oh,
So, I'm going to work through it, but you're going to tell me how I'm going to work through it, okay?
I said let me have it on my own.
I got a better idea. If you guys will get with us, this will be really cool. If not, I'm going to look like an idiot.
His noises make me really uncomfortable messing around. I think you're gonna have to move to a different class. Like that one right there, you don't ever wanna hear that. I think that number is
So, whenever you're dealing with this big of a problem, you have got to do something to help yourself out. Make a plan. Go back to the plan. You guys are not used to doing the big, massive steps, a bunch of steps within a problem. You have tons of confidence on the small steps. That's a good thing. All you have to do is multiple small steps. Make a plan. Where am I starting?
Your unit.
Somebody said it. Somebody said mass. And how we know that is because we looked at the what, David?
Unit.
Very good. Okay, so we're starting at mass. Where do I want to go?
First, we need to go from kilograms to grams.
Very smart. I like where you're going. Let's finish the plan. So we gotta get from mass, we need to go kilograms to grams. I'm gonna stop there for a second. Let's address this, because this is what makes these things challenging. The little subtle details matter. You have to go kilograms to grams. Why?
That's how.
It has to be in grams.
It has to be in grams, but why?
That's all
Like, that's the base unit.
Oh, the elemental table.
The elemental table,
What's the units off the periodic table?
grams.
Grams, yeah.
Per,
Mole.
so we get grams per mole. So whenever we're doing this, we have to be in grams. Good catch, okay? All right, so I'm going from mass where? Where do I want to go? Where are we going? Molecules. I have a question for you. Can I go straight from mass to molecules? No. Mole conversions, you either start with, go to, or go through moles. In this case, we're in a third step. We have to go through it. So we're going to go from mass to moles,
Then the molecules.
then we'll go to molecules. Is there a special number I need to go from moles to molecules?
Yeah, 22.4.
Oh, whoa. No, that's volume.
Avocado's number.
Avogadro's number, or as you like to call it, avocado, 6.022 times 10, 23rd,
I got that
and the
one.
units is molecules in this case, because I'm asking you for molecules. Now, there's how you need to look at this problem. You did mass to moles. You've done metric conversions. You've done moles to molecules. You've done every bit of this step already in this class. Now you just have to execute them all together. Got me? So let's start with it. First,
Kilograms to grams.
let's do the kilograms to grams. So I get 10.7 times 10 to something another, and that's going to be grams, but that's going to be of calcium hydroxide. I'm going to set it over 1. Now I got to find the exponent that goes with this. So let's do the metric conversion here. You walk me through the metric conversion. What's the first step?
I'm writing this down.
Hog, sorry. Sorry, Mr. Hogg just gets really excited because now we're doing the difference in prefixes. Okay? So let's look. What is the same between kilograms and grams?
The G.
Is G. So that's the base unit. So we look at the difference in the prefixes, right? What's the exponential value for kilo?
Someone else look at that,
I want to say it's
Exponential value of kilo.
6.
3.
Oh, I guess.
Difference is subtraction. So it's 3 minus, what's the exponential value of, well, it's just grams, so it's just base unit. It is
0.
0.
That's stupid.
3 minus 0 is
3.
3. There's no square on the units, and I didn't start with an exponential value, so I don't have to multiply or add. So my exponent is 3. Now I've got to mass to where I can convert. So now what do I need to do?
Run the moles, man.
I gotta get to moles. How am I going to do that? Tell me the conversion factor.
We're going 2 moles.
1 mole over
Mole goes in the top.
1 mole
Give me that
of
average-
calcium hydroxide.
Average atomic mass of calcium hydroxide on the bottom.
So what unit?
Great.
It's grams of calcium hydroxide. Here's the fun part. Is calcium hydroxide an element?
Probably not.
No, it's a compound. It has multiple of them added within it, so we have to find something called the molecular mass. So we have to calculate this right here. This is the thing I told you I was going to break down with you. Okay? Pardon, there you are. So, steps to calculate molecular mass. I'm going to write the steps as we're working through it. Leave you plenty of room here. You need a few lines. Make sure you get your steps in, okay? Step 1, you will write down each element that shows up in the compound / molecule. I'm not so concerned if you can explain to me what a compound and molecule is at this point. That comes later on in the class. What all compounds are is just things bonded together, pretty much. Molecules are compounds, but we call it molecular mass, so I wouldn't give it to you. So write down each element that shows up in the compound / molecule. So in this case, we're going to take the calcium hydroxide and we're going to break it down for each element that shows up. How do I know what the elements are? Here's the rule with chemical symbols. The first letter is always capitalized.
And there's only 2 letters.
Second letter of a chemical symbol is always lowercase. So if they are capital letters, you're looking at another element. If you have a lowercase letter next to a capital letter, then those 2 letters combine to give you a chemical symbol. So in this case, the C and you see the small a,
Those are 1.
that's 1 element. That's calcium. But then you see the O. Yeah. I can tell we've went to something that nobody has confidence in anymore. Everyone's shut down.
I'm good, then, let's go.
Of oxygen, and then hydroxide.
So the O is,
Hydrogen.
is oxygen. H
Hydrogen.
is hydrogen. Write it down. Step 2. Take the number of atoms per compound and multiply by the elements average atomic mass. I'm slowing down so you can write, if you want to know why I've shut up.
Mr. Earl, come here.
Yes. On it.
You see, we got the E25. They got 4 places best decimal, and you can't do that. You gotta do times 10, and 25 is the exponent. And you gotta put those units with it, because right now you don't have units. Overall, that's a good job.
Man, I'll do a pretty stinking good job, man.
I don't know.
So, how many calciums are present? Is there a number next to calcium?
There's just one of them.
So there's just one. Look at oxygen. How many oxygens?
Two.
There was 2. Why is there 2?
Because you've got the SO2, and it's in parentheses.
So you distribute that in. So there's 1 next to oxygen and a 1 next to hydrogen, but there's a 2 on the outside of the parentheses, which means we multiply, so there's 2 oxygens and 2 hydrogens. Do you understand that? If you do not understand that, you can just stop me now. All right. We multiply this by the average atomic mass of each one of the elements. So calcium's average atomic mass.
It's 40.08.
Yes.
40.08.
Looking at it?
And then
So
for
40.08
oxygen would be
grams per mole.
36. No.
Then oxygen is
16.
16 grams per mole.
32.
Hang on. Before I go any further, because I may be moving too fast, I need to be mindful of that.
You're good.
One thing I will do to help you guys is I'll do stuff like this. So I would tell you that Z is 20 and 8 and 1. What this is, these are the atomic numbers of those elements. I won't use a plus sign, I'll use more of an and sign, but I will break that down to you so that you know. The reason I'm giving you those is so that you know where to find your elements on the periodic table, okay? If I give you an element, you don't know where it is, just ask me, I'll tell you. So like the perfect example is hydrogen is number 1, here at the top left. What's the average atomic mass of hydrogen?
1.01.
Very basic.
1.01. Does everybody see that?
Yeah.
I want to make sure you know that. You have to know that in order to solve these. So you multiply these out, you get 40.08 grams per mole. Get 32.00 grams per mole. Then I get 2.02 grams per mole. Step 3, add all the numbers from step 2 together. I get 74.10 grams per mole. I did hear people typing in calculator. I didn't use a calculator, so if I'm wrong, feel free to correct me. This is your opportunity to correct me. I'm assuming I am correct. Math be math. So what are we going to do with that number?
Plug it in.
We're going to plug it in. I'm going to take it up here and plug it in. So 74.10 grams. You've done a lot of work, and this is where I'm saying, this is a lot of work. This might be a little new to you. Everything else you've done though. So we slowed down here to make sure you know how to do this. You've done a lot of work now. This is where the plan is useful to you. Have we reached the answer we want to yet? Look
No.
at the units.
I think that's fine.
Grams of calcium hydroxide cancel out. I'm left with moles. what did the question ask me? I started with mass, but I'm trying to get to,
Molecules.
but am I there?
No, you gotta find moles first.
No, I'm right here at moles.
You gotta find it.
Here's the option you got. You can do this math in the calculator, hit enter, and then reset up the next conversion factor, or you can just go ahead and set the conversion factor next to it and we throw it all in at once. I'm going to set it all up at once. That's what I like to do. No reason to do more work. So don't even look at this over here now. This is where we are. I'm going from moles to molecules. So I gotta set a conversion factor. If I'm going moles to molecules, what goes up top?
Avogadro's number.
Avogadro's number. I'm running out of room, man. What goes on the bottom?
What are we leaving? Moles? Moles. Moles.
Moles, thank you.
Uno more.
You get where I got that from?
Yeah.
Questions? Moles of calcium hydroxide cancel. I'm left with molecules of calcium hydroxide. Where was I trying to get to?
Molecules.
Molecules of calcium hydroxide. Boom, we're there. Now, we just got to type it in the calculator. And
8.695 times 10 to the 34th power. Oh no, I forgot my email. Molecules.
you will end up with 8.6957 times 10 to the 25th molecules of calcium hydroxide. Okay? So, I do. A lot of confusion that people are having is on the problems that I'm giving you. I put this.
That's just a number on the periodic table.
All this is the atomic number, like Towers is saying. It's a number for you to find the element on the periodic table. Why did I put it on here? I put it here so you get used to it and familiar to it. You guys are actually proving my point. If I would wait to give this to you on a quiz, everybody's going to see Z equals 9. Like, oh my gosh, I gotta use 9 somewhere. Where am I supposed to put 9? Where's 9 go? And there's several of you that are feeling that way. That's why I'm doing it now. So I'm trying to get you used to it. Do you need to know that fluorine is 9 on this problem? No. You don't need to know that at all. It doesn't matter. The reason I put it is to get you familiar with it so that you know when to use it and when not to use it. The only time you're going to look at that atomic number and have to use it is when you're dealing with mass and you got to use the periodic table. It's just the location of where it is for you because you do not know where the elements are yet. And that's okay. I don't want you to know where they are right now. I want you to be able to do mole conversions. So, first one. I asked how many moles are in a 12.6 liter sample of fluorine. So, question I have for you, where are we starting?
12.6.
So, we're going to start at volume. The reason we know that is what unit is with the numbers. The L, which stands for?
Liters.
Liters. Since you're at liters, you know you're starting at volume. Well, where do I ask you to go?
Moles.
I want you to go to moles. So we're going from volume to mole. Can I go straight from volume to moles? Yeah, you bet your bottom dollar I can. We can go from volume to moles, no problem. So let's set it up. Take your number, write it down. So it's a 12.6 liter sample of fluorine. Why did I put a 2?
Was God, I think it was JD, something.
Okay, Jody.
Fluorine is one of the 7 diatomics. Am I gonna hold it against you if you did not put F2 on this?
Yes.
No, I'm not. Some of you are not even putting at the end of this moles of fluorine. Really don't care. You better have moles, but you don't have to have moles of fluorine. The reason I'm putting the F2 now is I'm mentally getting you set on it to see it. Because when you deal with mass, this matters. Don't worry, Mr. Hall will get you with it tomorrow. So 12.6 liters. I set it over 1. So all I've done is took the number I've started with and set it over 1. No unit goes here, but now we need a conversion factor. We set the conversion factor. We look at our conversion factor. Where am I going?
Mole.
So what goes on the top?
1 mole.
So 1 mole. Where am I leaving?
Liters.
So what goes on the bottom?
22.4.
Why am I looking at that? Look what happens.
Cancels.
Liters of fluorine cancel. Leaves me with moles, which is what I'm trying to get. So I'll punch that number in. Do I multiply or divide? I divide the numbers in the bottom. Divide by it. You should get 0.5625 moles. Now, here's the point. If you have that, you're correct. You can even do that if you want to. Units there, you're good. I, just out of force of habit, I'll either put my molecule compound or element there. You don't have to, but I choose to. Questions on that one?
No.
You're starting to feel good about yourselves, yes. Now, so look at the second one. Second one we had, determine the volume of a 1.77 mole sample of carbon dioxide. I have Z equals 6 and 8. What's the 6 and 8?
Where is it?
Just where it is on the periodic table. Do you need to use that information?
No.
No. So, where am I starting?
With 1.77 and 1.
So, you guys are jumping ahead, that's fine. So 1.77 moles carbon dioxide. Where am I trying to go from moles to where? Volume. By the way, I should have told you this to start with. I messed up when I typed this out really quick this morning because something wasn't working for me, so I had to type these out and print them out really quick. Mr. Hall forgot to tell you at STP, but these are both at standard temperature and pressure. Don't worry, Mr. Hall will make sure you understand the motto. Now, I'm trying to go to volume. Can I go straight from moles to volume? Yes. So we must do what? 22.4 liters of carbon dioxide over 1 mole of carbon dioxide. Moles of carbon dioxide cancel. Do I multiply or divide?
Multiply.
Good job. And we get 39.648 liters of carbon dioxide.
It's such a chemistry whiz.
How you feeling?
Pretty good.
Okay, here's the thing.
That was
Okay?
over here trying to tell us we had to do metric conversions.
Yeah.
Yeah, we were done with both problems.
I thought it could only be there.
We were done with both problems, and he's like, I know what I'm doing. And then he says that we have to do a metric conversion. He goes, what did you get for the metric conversion?
Well, don't worry. You do have to do metric conversions. You have to catch it. Here's the thing I'm going to stress to you now. On this one, on these two you didn't, but you will have to do
Hey,
metric
you
conversion.
didn't on these ones.
So listen, here's the thing, guess what we've done? We went from mass to moles. We went from moles to mass. We went from moles to atoms, particles, molecules, formula units.
Jacob Muncy to the office.
We went from atoms, molecules, particles, formula units to mole.
Okay.
We went from mole to volume, and we went from volume to mole. You have done every step. Here's the thing now. We're gonna make big picture.
Okay.
We're gonna bring it all together, and we're gonna start doing some harder problems. Don't freak out at this. Because whenever I say we're gonna do harder problems, everybody goes, oh my gosh. Literally, what you've just done is what you're gonna keep doing. But there's multiple steps now. So you have to use the steps to get you to where you wanna go. So we need a problem.
Oh my gosh.
Alright, here we go. What'd you say? You tell me that your math class is harder after this.
I would like to.
And then she said she didn't have no money.
Wait, what teacher ratted the person out?
I ain't telling you that.
Well, that might help me figure out.
I can tell you that because I still want you to keep talking whenever we get to harder stuff. It's like math class is harder. Game on. Alright, determine the number of
Game on. Let's see back
a
there.
molecule in a
No.
15.3 nanogram sample of why not? Magnesium hydroxide. Alright, I'm gonna talk as you write that down. Listen to me. Don't freak out. You see a lot of things on here. This is the whole purpose and reason I've designed these lessons the way they go. You've done every step you need to do here except for one thing. I had showed you, but I'll go ahead and tell you, we're gonna have to calculate molecular mass. Don't worry, Mr. Hall is using this to teach you how to calculate the molecular mass. I'm going to give you the steps to how to calculate it. So, we're going to make a plan first. You guys are not used to doing tons of steps in things. Make a plan and use the plan to help you. So let's get a plan. You've been making your plan, you just didn't know it. First thing you do with the plan is determine where you're starting. How do you determine where you're starting at? Look at the number. What unit is with the number tells you everything you need to know. So go to the number, 15.3, look at the units that are next to it. Nanograms. What is nanograms a unit for? So I'm starting at mass. Now, I'm not releasing you to do this problem on your own yet because we'll make sure everybody's ready. So, I'm starting at mass, but what I want to do is I want to go from mass to where?
Molecules.
I want to go to molecules. That U looks like an N.
So you have to go from.
Yeah, you just need to work on the handwriting.
You go from
It'll print you out those dotted line sheets.
the
I
red.
got the
and
perfect spot to put them. I give them the hand and let her mark on. I'd hand them out. Y'all would actually believe it was me. Here's the thing though. Whenever you're doing a mole conversion and you're starting in mass, what must it be in? It has to be in grams. What are we in? They're nanograms.
So you have to go from mass to mole.
Here's the key. I've showed you all the steps, but now you have to catch the tricks along the way. This is a trick. Did I tell you you have to convert that?
No.
No, but you have to know to convert that. So you have to know, you have to be in grams. So when it comes to mass, for me to get anywhere, I'm gonna have to go from nanograms to what?
Grams.
I gotta get into grams first. So can I go straight from mass to molecules?
No.
No. Where do I have to go first?
Mass to mole.
You're gonna go mass to mole. Everything you're gonna look at, they're called mole conversions for 3 reasons. Number 1, you're gonna start with moles. Number 2, you're gonna go to moles. Or number 3, you're gonna go through moles. In this case, we have to go through it. Then, where am I going after moles?
Molecules.
Molecules. Is there a special number that I need to use to get from moles to molecules?
Yeah, the avocado do.
Avocado. So Avogadro, 6.022 times 10, 23rd power, and the unit is molecules. Well, how do I know that? Well, I gave it to you in the question. So now here's what we're going to do. Let's work the problem. We have a plan, trust the plan. So we're starting at mass. We got to get to grams first. Let's set it up. 15.3 times 10 is something another. After I'm done with this, I'm going to be in grams of the magnesium hydroxide. I set it over 1. Now, all I have to do is I have to find the exponent for my new number after the metric conversion. So you guys should be good with this. First thing we got to do in the metric conversion is find the difference. So I have a G in both of them. So that's the base unit. First one I have is nano. What's the exponential value for nano? -9. We're finding the difference, so we'll subtract. What's the exponential value of the base unit? 0. So -9 minus 0 is -9. You don't have an exponent on the units, and you don't have an exponent number that you start with, so you don't have to add that in. So the exponent is -9. Now you caught that metric conversion. Bravo. So now let's move. We're going to go from here, and we're going to go into the conversion of going from mass to mole. So I need a conversion factor. Listen carefully. In this conversion factor, what unit is going on the top? Mole, because I'm going to the mole. So 1 mole, magnesium hydroxide. What unit, just give me the unit right now, goes in the bottom?
Gram.
Gram. Good job. So grams of magnesium hydroxide. So now what we have to do is we have to figure out what this number is here for grams. In order to do that, what we have to do is calculate the molecular mass. So what I'm going to do for you is, as we do it, I'm going to give you the steps to calculate molecular mass. There's 3 steps, so make sure you got plenty of room for it. I don't know how big or small you write. They're full sentences. Some people are gonna call them run-on sentences. They're probably correct. They probably are. I'm not worried about punctuation. I'm worried if you can calculate molecular mass. First step. Step one you would do is write down each element present in the compound / molecule.
Willow Spence, City Office.
So what we're gonna do, we're gonna write each element that's present. Here's how you determine how many elements there are. The rule to the chemical symbol when it comes to element. First letter is always capitalized, second letter is always lowercase. So in this case, you see the big M and the little g, that's one element. Magnesium. Then from here, you go here, and you look at the O, one letter's capitalized. So you got O and you got H. That's two separate elements, they're both capitalized. That's oxygen, write it down. And then you have hydrogen. Step two. Step two, what we're gonna do, we will multiply the number of atoms for each molecule or compound by its average atomic mass from the periodic table. There's a lot of words on that. I'm pausing and slowing down, make sure you get them all wrote down. Are you need more room or are you good? I'm good. Okay. I was gonna tell you, just do what I do, man. Just pile it all up in a corner. I'll start digging when I need something later. Mary will do it. I think she doesn't mess with me. She'll just grab stuff and throw it all together. Like that thing was right here. So now what we're gonna do, write down how many are present. So here with magnesium, there's nothing written here. And it's just like in math class. When there's no number in front of the variable, there's understood to be a 1. There's no number there, there's 1 magnesium. Now I chose magnesium hydroxide on purpose because hydroxide has a parentheses with a 2 on the outside of it. That doesn't mean that there's only 1 oxygen and 1 hydrogen here. That means you have to distribute the 2 with those, so 2 times 1.
My bad. I read it.
You're up there. So just take that number and multiply it by with what's in there. So there's 2 oxygens, 2 hydrogens. Now you multiply that by the average atomic mass of each one of those elements off your periodic table. Do you remember on the entry slip how some of you were getting caught up on the whole Z equals, and I gave you numbers? In this case, it'd be like 12 and 8 and 1. This is where we're gonna use those numbers. You don't know where they're located at. These numbers are their locations. So if you go to number 12, you're gonna see it's magnesium.
Yeah, we-
What is the average atomic mass for magnesium?
24.31.
So 24.31 grams per mole. Go to number 8 on your periodic table. See, that's oxygen. What's the average atomic mass of oxygen? 16.00 grams per mole. Hydrogen's number 1. He was number 1. One of the greatest episodes. What? Thank you. Grams per mole. Then you'll multiply those out. So 24.31 grams per mole. 32.00 grams per mole. And then we get 2.02 grams per mole. Then step 3, you will add the numbers from step 2 together. I'll do that. I heard some of you popping in a calculator. I get 58.33 grams per mole. If I'm wrong, correct me. Now, what are you going to do with that number? We're going to pop it up here. So this number goes up here. So 58.33 is the molecular mass of magnesium hydroxide. Now here's the cool thing that happens. Grams of magnesium hydroxide cancel in the bottom and the top. I'm now at moles. So I've made it there. You're not done yet because we have to get to molecules. So we're going to set the conversion factor up. You've done this. I'm trying to go 2 molecules, so what goes in the top?
15.3 D, yeah, 3 of 9
Molecules.
divided by.
So then we have 1 mole of magnesium hydroxide on the bottom. So moles of magnesium hydroxide canceled. So now what we do, I've reached molecules of magnesium hydroxide. Now we just have to punch it in the calculator. So we'll take 15.3 times 10 to the negative 9, divide it by 58.33 because it's in the denominator, and multiply by 6.022 times 10 to the 23rd because it's in the numerator. Once you do this, you get 1.5796 times 10 to the 14th molecules of magnesium hydroxide. I know some of you are still writing, that's fine. The bell's gonna ring here in a couple seconds. I wanna let you know, you've done this, guys. All I did is combine the steps together. What did I do to try and trick you? I start you in nanograms to where you have to make the decision and catch. You have to do a metric conversion.
Well, then what'd you get in your answer? 120, okay, so.
Hey, tomorrow you come in here, I'm gonna hold off on the lab because I got your mindset where I need you to be right now. I want to practice this tomorrow. I don't know, you keep your entry slips today. I'm gonna go ahead and give you all credit for them. But I want you to keep them so you got them so you can look back at them. What we're gonna do is we're gonna start doing some hard ones.